This is a screencast for Properties of Exponents challenge using integer exponents. After watching the screencast, you should be able to simplify expressions using integer exponents. Before truly understanding this lesson, you should have a good understanding of using the rules of exponents with our natural or counting numbers, so that we can use those same rules with our integers. Then, in future lessons, you would be prepared to deal with rational exponents. So, to review, these are the properties of exponents that we have been looking at in this particular unit. And there are 7 of them, and what we're going to be doing is using a combination of these to simplify expressions. In our first example, we would like to know which of these 4 expressions are equivalent to 2 to the 5th over 6 to the 5th. I think the best strategy would be to take a look at each one of these independently and then see if we can make a match. So let's take a look at our first example. So 2 to the 5th over 6 to the 5th. In this case, I believe that I could aim for problem A by focusing on the 6 to the 5th. By using the rules of negative exponents, I can change that 6 to the 5th in the denominator to 6 to the negative 5th in the numerator. So I clearly can see how we get A as an answer. Looking at problem B, looks like what they're saying here is that we could just get rid of the exponents altogether and then simplify 2 over 6 to 1 over 3. But we don't have a rule for getting rid of exponents in general. So I'm going to think that this is not actually a rule that we could use. For choice C, I'm going to use our quotient rule and rewrite this as 2 over 6 to the 5th power. We can see how those two are related. Well, 2 over the 6, as we just discussed, does simplify to 1 over 3, but 1 over 3 is a reciprocal, so I could easily write this as 3 to the negative 5th power. So choice C is a possibility. For choice D, to get to the negative 4, what I'm seeing that they're doing is taking 2 minus 6 and making that negative 4. But for our rules of exponents, you don't subtract the bases. So I'm thinking that D is not equivalent. So the strategy that I used was taking a look at each one of our choices individually and then trying to manipulate our expression to get to the desired expression. And in the cases of A and C, we were able to use those rules of exponents properly. So those were the ones that worked. Let's take a look at another example. And here we're just going to simplify. So before I simplify, I'm going to follow my order of operations, and I'm going to try and simplify what's inside the parentheses as much as possible. So I'm going to focus on the 32 over 24, and that does simplify to 4 over 3. Next, I'm going to try and simplify x squared over x to the 6th. Using our quotient rule, that would be x to the negative 4th, but we prefer that our exponents remain positive, so I'm going to take that x to the negative 4th and rewrite that as 1 over x to the 4th, or in other words, x to the 4th belongs in my denominator. The next thing I'm going to focus on is y to the 12th over y to the 5th. Well, using our quotient rule, y to the 12th over y to the 5th is just y to the 7th. Well, let's neaten that up a little bit. And inside my parentheses, we've simplified to 4y to the 7th over 3x to the 4th. Now I'm going to take it one step at a time. I'm going to focus on that negative exponent, and I want to make it positive, and I'll make it positive by using the reciprocal. Then I'm going to use a combination of rules here to make sure that each term, the 3, the x to the 4th, the 4, and the y to the 7th, each individually gets raised to the third power. My next job is to simplify. So I'd probably use a calculator to figure out what 3 to the third is and what 4 to the third is. Then I'll use my power rule to rewrite x to the 4th to the third and y to the 7th to the third. So my final answer would be 27x to the 12th over 64y to the 21st. So those were two examples to help illustrate how we can simplify expressions using integer exponents.